Opia really allows you to deploy your GenAI applications in a very efficient manner. That's the bottom line.
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host. On today's episode, Embracing Private Gen AI with OPEA and special guest Arun Gupta, VP of Developer Services at Intel. Arun, welcome to the show.
Hi, Darren. I'm very happy to be here.
Hey, Arun, on my show, before we dive into the topic of the day, which is OPA, all of my guests are superheroes because I only have super people on my show, and every superhero has a background story, their backstory. So, Arun, what's your backstory?
Ooh, I got to think about it. So yeah, um, when I was growing up, my dad always used to say that when you grow up, which we are right now, you want to be
Are
like a
we?
banyan. Well, sort of, at least,
Yeah.
technically age-wise, right?
Age wise, yeah.
Age-wise, yeah. So my dad always used to say, when you grow up, you want to be like a banyan tree. And the reason you want to be like a banyan tree is because, banyan tree is a native tree of India. I know it's in other parts of the world as well, but it would provide shade to other people in the world. And the way tree grows is it grows from the root, goes up, drops down, and it grows up again and up again and up
Right,
again.
yeah.
And so that he would say that that is very humble, that is very hospitable, and that is very kind, because it's not just about yourself. And there are villages that would be settled underneath like a big palm tree, essentially. So he would say, when you grow up, you always want to be hospitable, you always want to be kind, and you always want to respect people, give them their space. So I think, frankly, that's been sort of my mantra for the last many years, is how do I make space for others? How do I create space for others? How do I learn from others? I think staying humble has been really important to me. Staying kind has been really important to me. And then whatever comes along the journey, we take it for a ride.
I love that. Your dad is a wise man.
He,
I,
he is. He is. I'm really blessed that I still get to take care of him on a daily basis. He lives with me. So I think it's just fantastic.
what a great tribute to your father. So,
Thank you.
um, with those tenants that you have, you've built a pretty strong practice inside Intel that a lot of people don't even know about, which is our developer services practice. You're the VP of Developer Services. A lot of people don't even know how much we do with developers at Intel. And one of the big initiatives is OPA. Do you want to describe a little bit more into what kicked this off? Was it the AI revolution that really kicked it off? How long ago? How have we been working on it? Or are we just tagging on to something that's already been done? Give me kind of a little bit of background, then we'll dive into it a little bit more.
Yeah, totally. I'm the VP for developer programs. So, as that VP of developer programs, my role is dev to dev. How do we make developers very effective users of our technology? So, we do workshops, tutorials, hackathons, all sorts of fancy stuff, events, blogs, podcasts, all sorts of fancy stuff, videos, to reach out to developers in masses. So, that's my role in general at Intel. Now, Opia, Opia rose by the same, different name would smell as sweet. So go by whatever feels comfortable, natural to you. But I call it Opia, Open Platform for Enterprise AI, was announced at the Open Source Summit, Seattle, last year in April. And frankly, the way it came about to be, within Intel, we started recognizing that everybody is kind of jumping onto the enterprise AI bandwagon. They're trying to leverage AI and be more effective, productive users, and cut down their ticket resolution time, do coding more effectively, et cetera, et cetera. And when we started talking to customers, we recognized that is exactly what they were doing as well. And so that really kind of started the effort inside Intel, that, hey, how do we build something like this so that there is less duplication, more coherency, more cohesion across different teams? So we started something, building something together. And open ecosystem is very much the foundation of what Intel does. So from the very early on, the decision was that whatever we build, whatever name comes out to be, but then we're going to release it in the open source. So it was a very, very quick exercise. We built something and we released it to the open source world back in April of 2024. And it turned out to be a great success, actually, since April of last year. Um, so what Opia is really, think of this as a three different pieces. One of them is, component level microservices. You know, Actually, if we take a step back, Opia really allows you to deploy your GenAI applications in a very efficient manner. That's the bottom line.
Okay, so let's talk about that part first, because a lot of Gen AI applications that are written today are being written on laptops or on single servers. They're in what would we call them? Science experiments. They're in sandboxes. But taking something from a sandbox and moving it into production is a big leap. And Opia is supposed to help me with that big leap, or is it focused just on the sandboxing and how do I experiment and try new things? Because I've been a CIO and I'm a programmer myself. I still do it for fun, and there's a big difference between what I write from my laptop and when I move into production in the enterprise. Huge difference.
There always is, right? I mean, and that's the impedance mismatch that we talk about all the time. So one of the big things with Opia is because it simplifies your GenAI app development and taking into production, the basis of Opia today is cloud native. And so the whole idea is when you are building a Gen AI application, think of it this way: like you're building a chatbot where you want to inject your enterprise data to the chatbot and saying, now when the chatbot is responding to my queries, it should have access to that enterprise data, right? That's a very
So that's
typical.
like a rag model, right? We
That's
talked
a
about
RAG model.
rag,
That's a
rag,
RAG
rag
model,
on the.
exactly.
Okay, so it's a
Exactly.
rag model. Okay,
Yeah. Well, I mean, RAG could be used for multiple purposes, but what you're saying is RAG with a chatbot front end, essentially,
right.
right? So
Okay,
that's what we are building. Now, when you're building that, from a surface it looks great, but then when you start digging into the details, you need a vector database because that's where you're going to store your enterprise data, or a graph database or a relational database with a vector front end, because that enables the ability to do similarity search, so
right.
that when I'm asking a question that, hey, is my issue resolved, it can look for similar issues in that vector database, which is your enterprise data, and say here could be potential reasons why you may be facing the issue. So that's one. The other big component that you need is a LLM, large language model, because that essentially has a reasoning capability, or a SLM or a small language model, depending upon what kind of accuracy, what kind of performance, what kind of TCO you are looking for. So those are two big pieces. Those are the two big known pieces. But then there are other pieces that goes along with it, which is once you have your data, can I put PDF as it is into it? No, because then what you do is you take your PDF documents, which is your where your
Convert it
enterprise data is
to
sitting.
text. Yeah.
Then you take that PDF, you chunk it, you create embeddings, and then you store that into the vector database. So essentially the idea here is that what you're doing is you're taking that entire PDF, ServiceNow, Salesforce, Slack messages, you're creating the chunking and the embedding and putting them into the vector database. So that's the data prep phase. Now, when a query comes in, then you need some other components: retriever, re-ranker. So there are a few 7 to 8 to 10 components that you need in order to even get the basic RAG chatbot up and running.
Right.
And that's the role that Opia plays. Opia is basically predefined set of those microservices, what we call as a component level microservices: vector database, LLM, SLM, retriever, re-ranker, you name it. And it's those predefined set of those component level microservices. Using those component level microservices, it defines what we call as Gen AI blueprints. And those Gen AI blueprints is a RAG chatbot. So a chat Q&A, for example, right?
Okay, so by bringing the different groupings together, I can produce different types of AI or Gen AI applications. Is that the idea?
Exactly. Exactly.
Okay.
Now let's go further down the rabbit hole for chat Q&A, for example. That's my typical Gen AI blueprint, right? Now, let's say I all of these microservices are containers, right? They are
Hmm.
containers
Yeah,
essentially.
yeah.
So
Docker
that means they could be
containers or
deployed on Docker, Compose, or Kubernetes or whatever. The best part of being a Docker container is it kind of cuts down the impedance mismatch that you and I were talking about earlier.
right.
If it works on my laptop,
It'll
is
work
much
in the
more
data
likely to
center.
work on the cloud in a higher scale as well. So what we do is we publish the Docker container for those component level microservices, and then I could spin up on my local laptop using Docker Compose. So it's a simple Compose file, say Docker Compose up, it
And
fires
then
up all of
boom.
those microservices, da, 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 and now I have a chat Q&A up and running on my local laptop. Great for experimentation, great for playing around, but now you want to go to the next level. That okay, I'm ready to scale this application. So then typically you deploy using Kubernetes. So what we provide are corresponding Kubernetes manifests or Helm charts for those as well. So you can say, I want to go to a Kubernetes cluster, whether running on-prem, whether running in the cloud or in a data center, we don't care. If you have an upstream Kubernetes cluster, then you can take that Helm chart and you can deploy that into your Kubernetes cluster, and it's going to give you that exact same experience.
It's the exact same containers, just with Kubernetes, it's more enterprise. So I'm sure there's redundancy, there's scalability. What about, because enterprise is a different beast than just a sandbox, and one of the biggest ones is data privacy and security. Innately, most people are just caution to the wind when it comes to Gen AI around security. How do we handle security with OPA? Is there a security model? Is it what's the approach there around security in private Gen AI in this
Yeah,
model?
so I mean, if you think about those component level services that I talked about, where is your vector database sitting? Is it sitting on-prem? Is it sitting in the cloud? Let's say you're in a country where your data can never leave your jurisdiction, right? So then you may want to hold the data in your control, where you say, I'm using a LLM like a OpenAI API, but then the data is in their control, in their jurisdiction. But if I'm
Wait, wait,
using that,
wait. Back up just a second, because I think this is a confusing part to a lot of people. Even if my vector database is private in my own data center, if I'm connected to a public Gen AI, then that data is being sent to that public Gen AI when I run my queries, when I run my prompts. Is that correct?
so think in that language, right? See, end of the day, my query comes in
Right?
and I extract the context from that query. Based upon that context, I query the database, I retrieve the similar information, and I send that prompt to the LLM. So in a
Oh,
way,
so I
part of
am
that,
sending my data to the
your
LLM.
data is going to the LLM.
Okay, so this is confusing for a lot of people out there because they say, "No, no, no, I have a RAG. My RAG is running on my laptop, and I'm using Claude, or I'm using Gemini, or I'm using OpenAI." And I said, "Yeah, and your data's going up there." And they're like, "No, no, 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 no." And I go, "Absolutely, it is, because you're doing is you're pulling that information from the database, adding it to the prompt, and sending the prompt again to the
That's correct.
Gen
That's
AI."
exactly what prompt engineering does. So because essentially you have extracted the data from the database, you put it as part of the prompt, and then you say, I've done the prompt engineering, and I'm going to send that to the LLM wherever it's sitting. Now there are multiple layers of privacy that you can do, security that you can do.
Okay.
So, for example, in the Gen AI world, there is this concept of guardrails, and guardrails is basically software that you can inject. Could be API driven, however you want it, but those guardrails could be sitting on the inbound data. So, for example, you say, my query has come in, I retrieve the data. Now, let's say the retrieval shows you SSN or some sort of a PII. Then I can start masking that information because the fact that it contains SSN is important. but the actual SSN may not be important,
May
right?
not be important. Right, right, right,
And
right.
actually should not be important, because essentially what you're doing is you don't want to expose, like today I make a request to a public and Gen AI model or a LLM, and then tomorrow you starts making query and say show me Arun's SSN, and boom, it just pops up over there.
That's right. Now,
So
that's an interesting point because I could use guardrails to also enforce data security, meaning who asks for the prompt? Do they have the right credentials to pull that data out of the vector database? So I could do that. I can inject my security right at that layer because, especially unlike Department of Defense, where I've got several different layers of security, but I could have a RAG sitting there that has all the data, and whoever has all of the security would have access to all of it, but whoever doesn't would be restricted on what data could be retrieved from the RAG.
correct. No, you can build all kind of fancy controls using
Okay,
guardrails.
cool.
Now that,
That's very very cool.
yeah, I want to mask the information, or don't want to reveal the
Prevent
information.
it, or yeah,
Yeah,
there's lots of things. Yeah.
exactly. Redacted. So multiple ways by which you can do that. The whole idea here is, because you want that RAG capability, RAG benefit, but doesn't mean you have to really expose your PII. So there are means and mechanisms by which you can literally trim it down.
So, all right. So, this is really cool because you've componentized the sections of the RAG architecture with different containers. I could inject my own container in there if I have a different need, as long as I'm adhering to whatever the APIs are between
Correct.
the.
Guardrails is essentially a container that you can inject in, and it will intercept your call to the LLM, and then it'll start saying, okay, here is what you want me to do, and I'll take care of that.
That's very cool. So it's a very pluggable architecture. OPA is, or
Well, and I think one of the advantages is exactly that, as you said, pluggable. Because let's say you built your chatbot with RAG using a 1 billion parameter model, and let's say your data today is only say 500 gigabytes, which is still pretty big for still
yeah.
pretty reasonable for enterprise size data, right? Big but not good enough for enterprise size data. So that is something you can probably test on your local laptop. But when you are going to say cloud, when you are testing on a say a managed Kubernetes service, say by Amazon, right? So what you could do is you could say that now I don't want a billion parameter model, because the accuracy, the response, the latency, the throughput that I get as part of that is not sufficient for me. I want to go for a bigger, better LLM, because now my LLM is kind of sitting up in the cloud. Then you can say that I want a more secure version of it. Then you can start putting, see, because security and privacy is never just the developer's responsibility. It's a shared responsibility, right?
Right.
Between the developer, the stack. Are you following the usual patterns for your application to be more secure and private? So I think, going back to the pluggability part of it, you could say I want a different LLM. Instead of having just 500 gigabyte data, now I want to use Elasticsearch as the backend, because that's my source of truth. Or I want to use a graph database, or I want to use OpenSearch Managed Service by AWS. That's where Intel has done their optimization. So that really opens the Pandora's box for you. And that's the beauty of pluggability. You have tested with something simple on your laptop, but now you're ready to scale, so you start injecting those different services to scale.
So my application code won't even have to change.
Exactly, because now all you're doing is your components are exactly alike. You're just changing your Docker Compose or the Kubernetes Helm chart and
Right.
say deploy
That
this accordingly.
no, that's great. Which also means that I can inject security constraints that my organization may have. And so if I'm doing app development, for example, and I'm developing it for the small green grow seed company, their security constraints aren't the same as the NSA,
Correct, correct,
right? But the application could be identical, but the
exactly.
security constraints can be injected in through guardrails and through some other containerized things that plug in. That's pretty cool. That's
Yeah, I
cool.
mean, a lot of repurpose, a lot of reuse, same concept. Depending upon the deployment environment that you're doing, you just modify the Kubernetes Helm chart and say, okay, here's what you plug it in, and then it becomes effective right away.
So the OPA uh, open source project, is that an Apache open source project? Where can people find out more about it?
Yeah, you can go to opea.dev. That is the primary website that we guide our developers to. Opia was contributed to LFAI Linux Foundation, basically. And
Okay.
within Linux Foundation, there is a LFAI and Data Foundation. That's where the project was contributed to because of the cohesion with a lot of other projects in that foundation as well. So that's where the project sits. When the project was launched back in April, we started with 14 partners, the big names that you would usually expect. Over the last, I would say, 9 months, we have added a whole bunch more, and now we are 50 plus partners today
Oh gosh.
that are part of this project, and several of those partners are actively contributing to the project. So for example, MongoDB, we are working with them on how they can provide like a document backend. With Neo4j, we are working how they can provide a graph backend.
A graph
With
backend. Yeah.
MinIO, we are working how you can have an AI backplane where unstructured data could come in and you can do things like that. So on and so forth. What I just talked about is a vector database category only, but similarly there are LLMs, that we are working on, different retrievers algorithm, different re-ranker algorithms. So, and that goes back to the whole pluggability aspect of Opia, that it doesn't matter, right? You can just replace that
Yeah.
one element in your Helm chart, that take this one out, put the new one in, and voila,
And
you
you're
got
off
the
to the
new
races.
service up and running.
Just as long as you can understand what the API is between that you have to adhere to.
Those different
That's
components, exactly. Yeah,
yeah,
yeah.
that's pretty slick. So they can go to opia.dev, find out more information, and kind of dig in and volunteer to contribute. That's pretty cool. This is such a hot area as well, that I imagine there's a lot of people that are really interested in more open source type of structures with this.
Very much so, because last year we were at reInvent, which had about 85,000 developers, and the team actually gave a workshop on Opia on AWS. You know, and one of the big things that we are seeing is, I was in India last month actually, and I was talking to a lot of developers over there. They were saying that we don't really need LLMs. We are okay with just using SLMs, small language
Yes,
models,
yeah, yeah.
and
I've seen the same.
that right, and that kind of feeds into the narrative that you don't really need like a GPU for running these models. And Intel Xeon is the most pervasive community across all the hyperscalers. So in that sense, tapping into that power of Opia, doing your inferencing on CPU is really getting traction across the industry, is what I'm seeing. So that's pretty exciting, actually. And frankly, I'm really glad that Opia is going to be an enabler for all of that. So, what we have done so far is we got the Opia solution available on AWS Marketplace. So,
Oh, that's great.
with a single click, literally, you can say, okay, now deploy Opia for me. Behind the scene, it provisions the Kubernetes cluster, it runs the open search container, it deploys the chat Q&A. All of that happens with you a single click. And we are working to build a similar solution for other hyperscalers as well. So essentially, you can just mimic that model, run it on any hyperscaler, and that's the direction that we are heading to.
Well, and what that does is it gives me as a developer the ability to focus not on my infrastructure. And now LLMs or SLMs or MLMs, right? Mid-size or language models, they now become just a service that I can tap into, which means I can focus on the new capabilities that I want to bring to bear instead of spending hours or weeks, because I have done it myself, standing up an LLM, standing up a RAG. It's There's a lot of components to get it right, and configurations, and especially when you move from one laptop or one host into a cluster of hosts, making sure all your IP routing tables are right and all that. It's a lot of work.
It is,
So if that's done for me, this is wonderful.
correct. And I think you're right, because you also got to think in terms of the opportunity cost. you
Yeah.
know can you do it? Sure, you can do it. I mean, you have done this so many times before, but do you want to do this, or you want to
I
solve
know I
your own
don't.
problem?
I
Right, right.
don't.
And that's where it comes down to, do you want to do this, and what's the opportunity cost or do you want to leverage Gen AI to be a more effective, productive, more efficient worker, user, developer?
And the latter is absolutely true. And because it's moving so fast, this helps me move even faster, which means I can stay in front of my competition for an application that I'm writing, right? Maybe it's a recommender system, or maybe it's I don't know. A great example. I have this project I've been working on for 10 years, right? It's this really cool thing that lets me architect systems much faster, right? Because that's what I do for Intel. I'm a solution architect. So anything I can do to automate the work that I do every day, I'm all in for it. I spent 3 weeks just integrating an LLM with it. And oh my goodness, when I didn't have to worry, I just grabbed an LLM, one of the public Gen AIs that are out there. And all I had to do was just tap into that endpoint and I was off to the races.
Right.
Just last week, I grabbed OPA. I got it up and running on my laptop in less than a half hour. And now I can run on my laptop completely disconnected from the internet and get the same functionality that I had before. That's incredible, right? I didn't have to spend the time to swap out a public for a private Gen AI. That's where we're headed. And I can focus on my application, which I'm having a blast with, because I just type in notes from my meeting and it starts making suggestions on architectural, and it's got all the history of all my other architectures I've done. It's slick, right? That's where I think the real power comes from these types of tools.
Absolutely. You are very well. When you look at the GitHub repo, for example, the Gen AI examples repo that we have as part of OPEA project, there are 20 plus such blueprints that you're talking about. Doc summarizer, FAQ generator, code translator, video Q&A, audio Q&A, chat Q&A. So you name it. And using those 30 plus component level microservices, we have created 20 plus different Gen AI blueprints.
See,
And
that's
the
awesome.
idea is we are inviting developers to tell us what more blueprints you want to see, take it a notch higher, contribute those blueprints to the OPIA project, because that's the beauty of being in an open source world.
No, I love the project. I'm glad that we're spending time and effort on this. Thank you, Arun, for coming on the show. And anyone that's listening, Arun has 2 more episodes he's going to do. He's written a book. We're going to talk about his book, and we're going to talk about something that's dear to my heart: non-technical skills for technical engineers. It's really important, especially now. And I'm sure we'll get into that a little bit. So Arun, thanks for coming on the show today. This has been wonderful.
Darren, thank you for the opportunity. I really enjoyed being here.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.